Hi, welcome to the quick review regarding the Fashion-MNIST assignment. We will be going at a fast pace, so there are inline comments in all the notebooks that help explain the code better. We started off by downloading all necessary packages and libraries. We moved on to setting up a random seed for replicability across all environments. Then we used a Kaggle website to create a mini data frame that shows the description of the product in relation to what numerical value that there will be. Now, we called the dataset directly from Hugging Face, and we attributed a train test split of 30 and then 15 and 15 for test and valid. We also attributed every train valid and test, we attributed to a dataset which is callable. We then did some data exploration, looking at the lengths to make sure it matches up with the source code that Ian gave. Then we used label ID to convert the labels into IDs, into numerical values. Then we called um, model that we were going to use, and we used also image processor, and which we got the resample height and size. We used 224 by 224 for this. And then here we did the data augmentation. We used resize, random flip, horizontal flip, random brightness, and normalize. It's important to note that we did two different transforms here, one for train and another one for valid. We created a function that allows this to take place. As you can see, there are inline comments that are commented out for you guys to understand the code more. Then we apply the pre-processed functions to the splits, and then we got a numpy array just to check how certain and how replicable it is. And then we use enum labels where we converted the labels into ID, and then just to convert it back just to be sure. So that's what we did. And then we ran the model with the training arguments that we have of a learning rate, a batch per size, a train epochs, a warm-up rate, a log rate, and the model accuracy of accuracy. We use the evaluate from Hugging Face, and we use a compute metrics function to look at the evaluation of the predictions in reference to its IDs. And then we also ran into a problem regarding how this data set was in black and white, while most transformers work in color. So we used a link from Geeks for Geeks to trick the model into thinking that it's in color. We've attached the link for you so you can review that as well. From there, we trained it with all these arguments, and we attached the variables to the right variables again, if that makes sense. And then this is our results. We have a evaluation loss of 0.0972, evaluation accuracy of 0.69, and a eval step per second of 2.559. All in all, there is that data, there is data augmentation, and there is the conversion of a lot of other things that make this model a very successful model. Thank you for listening. I hope you enjoy. If you have any questions, let me know.